far beyond the orbit of Neptune, in the cold twilight depths of the Kuiper Belt, lies a world that has captured our imagination for nearly a century. When it was first discovered in 1930 by Clyde Tombaugh, it was hailed as the ninth planet. For decades, it remained a mere speck of light in our most powerful telescopes, a mysterious outlier guarding the frontier of our solar system. We called it Pluto. But as our technology improved and our gaze grew sharper, Pluto revealed a secret. It was not alone. In 1978, astronomer James Christie was examining photographic plates of Pluto when he noticed something strange. The planet appeared to have a bump that moved around it over a period of about 6.4 days. This was no mountain, it was a moon. He named it Charon. The discovery of Charon was a watershed moment in planetary science. For the first time, we could accurately determine Pluto's mass, and the result was shocking. Pluto was much smaller than anyone had anticipated, but even more surprising was the size of Charon itself. Charon is roughly 1,212 kilometers in diameter, about half the size of Pluto. This makes Charon the largest moon in the solar system relative to its host planet. To put this into perspective, if the Earth were the size of Pluto, our moon would be the size of Charon. It is an astronomical anomaly, a pairing so extreme that it challenges our very definitions of what constitutes a planet and its moon. In fact, this extreme size ratio leads to one of the most fascinating and unique orbital dynamics in our entire cosmic neighborhood. In a typical planet-moon system, like Earth and our moon, the moon orbits around the planet. The center of mass of the system, the point around which both bodies actually revolve, known as the barycenter, lies deep inside the planet itself. The Earth wobbles slightly, but the moon clearly orbits the Earth. But the Pluto-Charon system is different. Because Charon is so massive compared to Pluto, about 1/8 of Pluto's mass, Charon exerts a tremendous gravitational pull. It pulls the center of mass completely outside of Pluto. The barycenter of the Pluto-Charon system lies in the empty space between the two bodies. Consequently, Pluto does not simply sit still while Charon orbits it. Instead, both Pluto and Charon orbit this invisible point in space. They engage in an eternal cosmic dance, circling a shared center of gravity every 6.4 Earth days. Because of this unique configuration, many planetary scientists and astronomers refer to Pluto and Charon not simply as a dwarf planet and a moon, but as a double dwarf planet system, or a binary system. It is the only known binary dwarf planet system in our solar system. While the International Astronomical Union currently officially classifies Charon as a moon, the reality of their physical relationship is much more akin to twin worlds locked in an unending waltz. And this waltz is deeply intimate. The gravitational tug-of-war between Pluto and Charon over billions of years has profoundly affected both worlds. They are mutually tidally locked. What does this mean? It means that their rotation periods have perfectly synchronized with their orbital period. They take exactly the same amount of time to spin on their axes as they do to orbit their common barycenter. The result is that they always show the exact same face to one another. If you were standing on the Charon-facing side of Pluto, Charon would hover completely motionless in the sky, a massive, unmoving sentinel, day and night, year after year. It would never rise, and it would never set. But if you traveled to the far side of Pluto, you would never see Charon at all. This mutual tidal locking is a rare and beautiful state of equilibrium, a testament to the inexorable power of gravity over deep time. For decades, our understanding of this unique binary system was limited by distance. 3 billion miles of empty space separated us from Pluto and Charon. They remained blurry pixels. But that changed on July 14, 2015. NASA's New Horizons spacecraft, after a journey of nearly a decade, flew through the Pluto system at over 36,000 miles per hour. During those precious few hours of close approach, it turned its instruments toward these distant worlds, gathering data that would rewrite textbooks and transform our view of the outer solar system. When the first high-resolution images beamed back to Earth, scientists were left speechless. Instead of the dead, cratered ice balls many expected, they found complex, geologically active worlds. Pluto was a world of towering mountains made of solid water ice, vast plains of frozen nitrogen, and a thin, multi-layered blue haze in its atmosphere. The famous heart-shaped region, known as Tombaugh Regio, revealed a dynamic surface where glaciers of nitrogen ice slowly churn and flow. Charon was equally astonishing. It was not a carbon copy of Pluto, but a uniquely fascinating world in its own right. New Horizons revealed a surface scarred by immense fractures and canyons, some deeper and longer than the Grand Canyon on Earth. A massive tectonic belt stretches across Charon's equator, hinting at a violent geological past where an internal subsurface ocean may have frozen and expanded, cracking the moon's crust. Perhaps most striking is Charon's northern pole, crowned by a dark reddish region informally named Mordor Macula. Scientists believe this red stain is actually atmospheric fallout from Pluto. Methane gas escapes Pluto's weak gravity and is captured by Charon's pole, where the extreme cold freezes it. Over time, ultraviolet radiation from the distant sun processes this methane into heavy, reddish organic compounds called thalins. In a very real sense, Pluto is painting the surface of its companion. The New Horizons mission also gave us an unprecedented look at the rest of this complex system. Pluto and Charon are not alone in their dance. They are accompanied by 4 much smaller moons, Styx, Nix, Kerberos, and Hydra. These tiny, irregularly shaped bodies do not orbit Pluto alone. They orbit the entire central binary of Pluto and Charon. Because they orbit a shifting binary center of mass, the gravitational environment they experience is chaotic. As a result, moons like Nix and Hydra do not rotate predictably like our moon. They tumble chaotically as they orbit, flipping over and spinning erratically, constantly buffeted by the shifting gravitational pulls of the 2 massive bodies at the center of their system. But how did this bizarre, beautiful system come to be? How do you create a binary dwarf planet with a retinue of tumbling moons? The leading theory points to a violent origin. Billions of years ago, in the early chaotic days of the solar system, the Kuiper Belt was much more crowded. Scientists believe that a massive icy body collided with the young Pluto. This wasn't a head-on shattering blow, but a glancing strike, a kiss and capture event. The impact blasted a massive amount of material into orbit around Pluto. Over time, this debris disk coalesced to form Charon. The angular momentum from this colossal impact would have spun both bodies rapidly, and over millions of years, tidal forces slowed their rotation, pushing them further apart until they reached the mutual tidal lock we see today. The 4 smaller moons likely formed from the remaining outer debris of this same cataclysmic collision. What we learned from this mission is that the outer solar system is far more dynamic than we ever dared to dream. The internal heat required to keep Pluto's nitrogen glaciers flowing, and to drive the tectonic cracking on Charon, suggests that these worlds are not completely frozen solid all the way through. Radioactive decay in their rocky cores might still be providing a faint trickle of heat, enough to sustain subsurface oceans of liquid water laced with ammonia. The possibility of liquid water, the fundamental requirement for life as we know it, existing in a binary system billions of miles from the Sun, is a paradigm-shifting revelation. Furthermore, the atmospheric dynamics we observed on Pluto present a meteorological wonderland. The thin blue haze, composed of soot-like particles called thalins, settles onto the surface in slow-motion snowfalls. This haze is organized into distinct layers, indicative of complex atmospheric gravity waves. We also see evidence of wind streaks on the surface, meaning that despite the incredibly thin atmosphere, about 100,000 times less dense than Earth's, there is still active weather on Pluto. Charon too shows signs of a complex past. The massive canyon system, Serenity Chasma, is one of the longest and deepest in the solar system. It stretches for over 1,000 miles and reaches depths of nearly 6 miles. This immense scar tells the story of a world that expanded as its internal ocean froze solid, bursting the crust apart. The smooth plains of Vulcan Planum in Charon's southern hemisphere suggest ancient cryovolcanism, volcanoes that erupted slushy ice instead of molten rock, resurfacing vast areas of the moon. Every detail we uncovered about the Pluto Charon binary system underscores its uniqueness. From the shared atmosphere painting the moon's pole, to the chaotic tumbling of the outer moons, to the geological marvels on their surfaces, this system is a treasure trove of scientific wonders. It is a natural laboratory for studying planetary formation, tidal evolution, and the complex interplay of gravity in a multiple-body system. As we continue to analyze the wealth of data returned by the New Horizons spacecraft, new mysteries continue to emerge. Scientists are still puzzling over the exact composition of the dark material on Charon's pole and the precise mechanisms driving Pluto's atmospheric hazes. The intricate details of the system's formation are still heavily debated, with computer simulations running constantly to model the physics of that ancient, cataclysmic impact. Every new discovery only deepens our appreciation for this remarkable binary system. The complex interplay of orbital resonances, tidal forces, and geological processes makes Pluto and Charon a unique case study in planetary science. Their ongoing dance provides a critical window into the conditions that prevailed during the dawn of our solar system, offering clues about how other planetary systems might form and evolve around distant stars. The legacy of our mission to the edge of the solar system will endure for decades, inspiring a new generation of scientists, engineers, and dreamers to look up at the night sky and wonder about the worlds that still remain unseen. We have only taken our first steps into the Kuiper Belt, and the double dwarf planet stands as a shining beacon, inviting us to venture further into the unknown. The story of Pluto and Charon is a reminder that the universe is vast, complex, and full of surprises. It teaches us that even the smallest, most distant worlds can harbor incredible complexity. Our exploration of this binary system has reshaped our understanding of the Kuiper Belt, revealing it not as a graveyard of frozen debris, but as a dynamic, active region of our solar system, populated by worlds with rich geological histories. The lessons we have learned here will guide our future missions to other dwarf planets, such as Eris, Haumea, and Makemake, as we continue to map the uncharted territories of our cosmic neighborhood. We are just beginning to scratch the surface of the wonders that lie in the deep outer solar system. The dance of the double dwarf planet continues, a silent ballet at the edge of our solar system, echoing the violent and beautiful history of our cosmic home.
If you enjoy this content and want to see more, please consider subscribing. A quick tap on the like button also helps us learn what topics you like best. Thank you for watching this video, and see you in the next one.